email from Sam. So Sam sent us, oh, here. This is going to be, so here I'll just, Sam, are you there?
Yes, I am here.
You want to send me a copy of your model? Let's see if we get the same numbers that we get in our model, because you have a different data source for the flows, right?
Yes, yeah, I actually did this last night, so I don't have the data that you had sent around earlier.
That's what makes it interesting. It's interesting to see if we have a different report. Where was your data from?
It's definitely not perfect. I used US import data for some of the trade flows, and then I used some ComTrade data too. And then there were some places that were missing data that I had to kind of put an educated guess in. So I thought, the purpose of the exercise was not to come up with a perfect data set, but to
No, that's true.
play around with it. So it's definitely not perfect.
Yeah, no, that's good. The thing is, it's less about the data sets, more just, I like the idea of illustrating the ease with which you can assess robustness of model results to data sources. It's like, this is one of the things I like about GAMS, is it's pretty simple to when you're doing a pivot table, that you can basically pivot up the results from a couple different things and see where things differ, right? So that's one of the things that's interesting. So if you wanted to send me your data, you could just send the table, or you could send your model, and I would just, this afternoon, when I put together the final SSA sort of example, I would include that as a additional tab, so you can compare across the data set as well across the elasticities.
Okay, yeah, I'll send you that.
That's great.
Thanks.
So, okay. So there's a, okay, so let me just look at this. This is C. Roos. Let's just see what we got here. I'm not sure if this is, there's one element here that Kashab asked about that I just point out. I've created a singleton set. It's this R target I declare as a singleton. That's a subset which has a single element in it. And so when you declare something as a singleton, then you can basically use it on the right-hand side. So here I use this, you can use it on the right-hand side, and that's mainly just for my reporting. I'm saying, I call it C-Roos, so it's the cost inclusive of the markup of the of oil from the target region. And so there, notice in this equation here that our coalition appears on the left-hand side, but our target only appears on the right-hand side. Normally GAMS would complain if you just had a set that's sitting on the right-hand side and it's not controlled on the left. But in this case, it's declared as a singleton set. So GAMS says, oh, that's a singleton. Okay, fine, I'll find the one element that's our target. So that's how that operates. Okay, so that's the same thing. So I'll come back to this at the break. I'm very close to getting this guy set up. I was hoping to do it anyway. I'll go through that after the break, the SSA example, which is at the template I give you, you can use for lots of different things. It's not so it's something that often, I find it's often the case. I get a model running, I start thinking about one set of connections I want to make, and I do some runs on that one, and then I think about the model again, and I have a different one. So it's quite common to have to generate the model lots of times, which is actually, it's not a problem. And I can also show you this afternoon how to, in the example, I'll include a thing that shows you how to use launch runs in parallel if it's the, oh yeah. So the parallel runs, I mean, if I go to the batch file, so here, the key thing is, instead of just saying GAMS model, just say start a low eta GAMS model. So just use a start command, start, double quote, label for that run, end double quote, and then the command you want to run. So that's syntax. And again, we can do this. So there I start them all, and it's going to happen so fast that you won't even see it. But if I say GAMS run, you can see they all start in separate windows and they run in parallel. So the start command is usually, it used to be something that only really nerdy guys know how to do, but now everybody has multiple cores in your machine. So this is always a good thing to learn how to do, is to queue it up, because that way you can have you can solve essentially on this computer. This is a relatively small laptop that was cheap. This was like a $1,200 laptop. I can run 12 processes in parallel, and it works just as fast as running one. So that's a useful thing to learn about for sensitivity analysis for controlling the model. It's not always the case. It's not the first thing to think about, but it's definitely something that's worth thinking about if you're running lots of different cases. So now I'm going to close these windows. Hide floating controls. Look to here, I can close this window. I go to my talk. So we're done with our we're done with simulation analysis, GAMS and Excel. I'll come back to finishing that up. And now we'll talk about the last three things I have. Something about WiNDC, origins and motivations. I'll go through the equations of the GTAP WiNDC model. And then I'll talk a little bit about policy applications with GTAP WiNDC for tariff quotas, just to show you how to sort of set up and run the model. And this is basically just explaining our latest release, which should be up in the next week, has the simulations I'll go through today. So I guess a number of people here have already seen this, but the basic idea here is that this work began with our collaboration with EDF on sort of state level climate policy. And we worked on trying to analyze the effects of trade and competitiveness effects of subnational climate policy. Our analysis was a little bit by, I had always usually worked with IMPLAN for doing sort of economic analysis within US states, but IMPLAN is kind of expensive, right? And also, so I didn't have a good funding source for whatever it was, $9,000. It's expensive to get a full set of tables at the state level. And furthermore, perhaps what's even worse about it than the money is that it's not so obvious to see where the numbers come from. It's numbers, it's a black box. Whereas you'll see here that we actually produced the code to show you the building of the data set. So if there's a number that you find that's funny, you can go back in the build stream and try to trace down what's going on. So that's I think that our main concern was how to do this. So can we build a set of transparent tools for producing subnational economic accounts for general equilibrium input? And I'd say general and partial equilibrium and input-output analysis. So equilibrium relies on constructed data sets. And so we have this micro-consistent state-level data sets, and looking at, there are public available regionalized accounts, but are not really readily available. And this was basically just taking things already publicly available and showing how to put them together. So this was the idea of the consortium. We had a couple of other objectives. So the transparency of the build stream. We're hoping to incorporate more census data. I'm hoping we can still get back to that. Connections to international data set, and that's what we've been working with. That's what I'll show you today, is a version of the data set that runs with GTAP. Can you capture there? And then we also wanted to have something where the build stream was accessible to people even who didn't have a GAMS license. So that was this NEOS connection. So our stuff was early on. I don't know that we've tested this with the most recent version, but okay. Okay. Yeah, well, anyway, we're hoping we can come back to learning to run this stuff on Neos is one of the things we worked hard on the first couple of years, and I'd like to get back to make sure that's possible. That makes it possible. You can load GAMS on your machine, not have a license, solve it with Neos, have a server that's done remotely, and it should work. We also want to have a connection of canonical models that run both in GAMS and in Julia Jump. I've been working with David Antoff at Berkeley, and his graduate student. Boy, his graduate student is a smart guy. Anyway, these guys are making good progress. So they're building a version of sort of an MPSG compatible version of a version of MPSG that runs under Julia, and that's kind of exciting as well. So that's something I'm hoping we can make progress with over the next couple of years. So, and then this gives you options for how to build. In the current data set, we primarily have the Blue Note data set, which is with the energy environment. We've got household data and we have a version also that works with sort of occupational categories. So, and the motivation was this sort of lack of transparency in the private source data, and the idea of producing open source tools for doing this was what we had in mind. So what we have going on here is that these downloads of all these data, the national input output summaries reads the data and maps all of the identifiers. So there's all this messy sort of upstream stuff that goes on. And that stuff is all done. It was Adam basically did the first pass. We're excited about having a new data scientist who's also really good at Python. So all this upstream stuff is using traditional data science tools for mapping labels and getting it cleaned up. So we get a cleaned up version of the data. Once we get that, then the matrix balancing and stuff is all done within GAMS. And I'll show you the matrix balancing we do with GTAP is one of the operations that's going on here. There's several different paths that we can go through. There are details of how this gets handled. So it's based on sort of national level summary tables from 97 to 2017. And it's all of the reconciliation work between these different data sources done using GAMS optimization tools. Yeah, so that gives us a sense about what the aggregations are. One of the things I'll introduce today is a version that's got a GTAP version that's got 11 regions and 10 sectors. Is that what it is, or 11 anyway? So we've got an aggregation that basically is publicly 12 sectors. Okay, so we have an aggregated model where we can give away the data. The GTAP guys are not too upset about it. I'm going to jump over the balancing stuff. So the regionalization works from state level tables that share out gross state product, personal consumer expenditures, state government finance tables, and USA trade statistics. So a variety of things. I mean, if we worked a little bit on the trade, there's right now the current version that we're releasing is one that basically has a pooled national market, but we have a couple of different. We've made passes through, and you can download earlier versions to try to look at other sources for bilateral trade flows. And so it's essentially then household demand, government demand, investment, and intermediate demand are the sources of absorption, and that gets reconciled. Let's see, so this is more about the regionalization, this is more about, and then we have issues about the trade flows, but I'm going to jump forward to the basic logic here. So the build routine then ends up with social accounting matrices for all 50 states plus DC from 97 to 2017, and the summary files of 71 sectors. When we go to GTAP, we end up with 32 sectors because we have to aggregate them both ways in order to get to a consistent thing. And there are methods you can do disaggregation. I'm currently working on a version where we can employ to disaggregate GTAP. We're able to use the XEO base EU data set for getting sort of disaggregating commodities. The XEO base has 200 sectors. It's not as detailed about the composition of economic activity, but it's got rough shares that could be useful if you have to get below the level that's provided by GTAP. Okay, so let's just first version of the data set is single representative agent for each state. And the newer version, we disaggregate that. So we have two versions of the household data set. Both are roughly on quintiles. I guess the CPS is more or less exactly quintiles. The SOI, which is the IRS data set, is and there's some difference, subtle differences between these. IRS is on a reporting basis. Anyways, there's difference. What's a household and what's the taxpayer basis. Some differences, but we held on to both those, and we're sort of something that's on our plan for this summer is to finish up our paper about how we do this. But this gives us sort of quintiles, and we reconcile the income balance, then reconciles the composition of wage earnings, capital earnings, and other income. And it also takes into account state level transfers. So a variety of ways that this sort of reconciliation with household data is incorporated. Yeah, so this gets at the household stuff, which is stuff we worked on this past year. So that shows the basic data sets. One is SOI is administrative data from the IRS, and then there's also this current population survey. We've been talking with Jim. There's a bunch of new work that's been done on providing more detailed breakdowns of households. So we're kind of excited about the prospect of actually continuing this work on identifying heterogeneity. That's the main sort of thing that I think motivated our interest in the approach, was to come up with a scheme that could do trade policy analysis and identify what household impacts are, both by geography and by income categorization. This gives you a sense about what the shares are. I'm not gonna. This was basically from some slides about the household. So you can see here that we don't have exactly the same categories. There's some slight difference. They roughly correspond, but they're not perfectly aligned. And you can see the CPS is exact quintiles, where the SOI is a little bit. The IRS data is not exactly the same. So let's see, I'm not going to go through this. So the key thing that we've got in the new data set is a integration of GTAP sectors. And so in this case, we have sort of 33 sectors representing categories within GTAP, and then those activities in the GTAP data for the US are broken down to match the states. So we're basically trying to maintain a handshake with GTAP at the national level, but then doing disaggregation based on shares we get from the WiNDC framework. So current version, and in principle, if you have a GTAP license, then you can run the stuff with your GTAP code, and then that'll give you any number of regions. We have using GTAP, a version of GTAP for GTAP 10. One of the things we'll release of the code for working with GTAP 10 data. It basically goes from the FlexAg specification down. Yeah, so that's basically the trade is aligned with GTAP, use matrix, final demand, household, endowment structure aligns with WiNDC. So we're trying to have some reconciliation. This is something we worked a lot on. Ala Golub from GTAP has been working with us. We've had meetings more or less every week for the last last 9 months. And so we've been working on this and we've made quite a bit of progress. There's still other things that could be improved, but we have basically come up with this 33 sector mapping. It took a lot of work to sort of identify consistency. So these are mapped onto different classifications and requires crosswalks between these guys. Okay, so let me show you what this model looks like. And now I'm just my idea was to bring this back, to go full circle back to our Matheson's framework and sort of go through the logic of this model. So what this is coming with, let's see if I can show this to you. Okay, so this does work. So I can share this with you guys. So I'm working with the documentation of the model. It's kind of cool because it basically, I've been working with Florian Landis. We haven't finished this yet, but the first pass thing works through here. And it basically, what we get out of this is a, well, let me first go through the basic logic of this thing. So if you think about, you have the data set that looks like this. It says, okay, what data set we want to use? And that's GTAP version, household version, and base year. The version I'm running here is from 2014, but we've just recently got the version 11 GTAP data that's got a 2017 base year. So that's something that will be available. So this is the 2014 data set here. So you say include GTAP WiNDC data. That goes out and grabs the data set that you've identified. So you indicate what data set you want to get. It goes and gets it. And then we've got the model. And if we look at what we've got, the model, it's got Y of G, R, and S. So the key, what's going on here is G is going to be all sector goods together with private consumption, public consumption, and investment. And then we've got, I'm sorry, G, I'm sorry, with the household data, we don't have private consumption. We have investment, public consumption, and all the other sectors. C of R, S, I, or H is going to be the consumption activity for region R, US, Canada, whatever. Subregion S, which in the states, in the US case, would be all the states. And H will be the household classification, of which there are 5. We have a disposition activity that basically takes good I and allocates it to the national market or to the export market. So it's using it's known as a 1, 2, 3 model where goods are produced and there's a differentiation on the supply side. And then we have this Armington demand activity, Z of I, R, S, sources absorption of good I in state S. And that's going to come from the national market or from imports or from the domestic market. So the thing is, within each state, you think about there being 3 different markets get produced for: one for producing in the state in which the production takes place, the other is to the US national market, and the other might be for exports. And then on the demand side, it's imports together with national market, together with local market. So that gives you a way of controlling what's happening. There's a FT activity is the factor transformation activity, which that's the GTAP specification where certain factors may be sector specific, in particular agricultural production or natural resource based sort of oil, gas, coal. There's an import activity M of I, R, which combines imports of good I in the region R. So that's capturing imports from other trading partners. And then we have this YT of J is the provision of transportation services used by international trade. So these are all the GTAP things. The main difference is we have this comma, anywhere you see a comma S or a comma H, that indicates that we have something different than the standard GTAP model. So we have the output price PY, the Armington composite price, the domestic local goods price, the import price, the national goods price. So P of I, R is sort of the national market, and that national market can either be used for export or for domestic absorption. And then we have a consumption price index for each of the households by each of the subregions. So it's got 5 household classifications for each state. So there's a total of 250 households in the model. Okay, so that gives us the definitions. And now I'm going to shift over. Those are all the definitions. And now I want to just shift over to this other format. I'll first show you what the MGE version 2 model looks like. And this is not, it's sort of work in progress, but it's kind of like, look, Ma, no hands. This is kind of fun. So here I have a definition of what the sectors are. So here I'm doing a bat include. MPSG says I'm going to start to initialize my model, and then I indicate what the sectors are. And in the sectors, I give what are the indices that drive that sector, and then what's the description of what that sector is. So all this stuff goes in the code. And then I indicate what the production blocks are, what goes where, and each of the production inputs and outputs is denominated here. Right now we have to write this stuff out So I look at the MPSG model, write it out, but we're in the process of developing something that will automate this. But we have that. Then basically, once we have this guy running, then we can run a compilation of this thing. And what the compiler does is reads the model, and then it will write out information about the model and structure that can then be intercepted and or can be interpreted, and that then will generate a file which looks like this. And so this gives you then a file. So from that file you had there, then you get some definitions of what the production structure is of the model. And the cool thing is it basically reads the GAMS code and writes out LaTeX. So this is what I'm working on is a version of the of basically the preprocessor, so that you can use MPSG and you can communicate to other people what's in the model, but you don't have to basically write out all the detailed GAMS code. You can still use it. So that's what we're working on. But just to go through what the equations are. Now this all goes back, the specification that's provided here goes back to the Matheson layout format, which has activity levels, and that's in his model. It's an abstract Y, and here are the categories of activities we have in the model. So that means that we're keeping track of these different goods, and then we have prices, and the prices include, so there's these composite output prices, local goods prices. Those are the three classes of markets you have in the model. And then you have national goods price, the consumption price by household, primary factor rents, sector specific factors. So that's certain sectors. And here we're following the GTAP specification. So in GTAP, the primary factors include land and energy resources. So those things are sector specific factors that are represented. And then you have an import composite price and transportation services. And that's the transport services are for international trade. And then representative household, and that's by R, S, and H. So for all regions other than the US in this model, there's only one S. So S is the subregion. In the US, the subregions correspond to states. In the other regions, other countries, that's just one composite subregion for each country. And then we have H. One of the things that's on our list, we have the Canadians have been very patient. They've been supporting the project, and they're keen that they have a nice data set that's at the provincial level. So we'd like to have, we can have a model where we have states for the US, we have provinces for Canada. There's a number of other countries that have subnational. The Europeans keep data at the NUTS 2, NUTS 3. So basically there's a variety of ways in which this could be generalized. And the key thing is you want to understand the distributional consequences of trade, both across income categories and across geography. So representative household for each country, for each subregion, for each household. We have public expenditure is by country and investment by country. And then here's the code. And I kind of like this. It's a little bit cryptic, but it gives you pointers to what's coming from things here. So the A indicates that's a net put vector, which has inputs are negative and outputs are positive. So that's going to be, that's got Y of S times A of I by S. That indicates, and the superscript PY, Y indicates that's the input of commodity, which has a price index of PY, into the activity, which has got a name Y. And so that's the output of VOM. And then we have the inputs there, which will be negative coefficients. Again, in Matheson's specification, A is just a net put vector. So outputs are positive, inputs are negative. So this represents the intermediate demand. And then here we have the demand. And I see looks like there's a bug here. I'm not sure why. I guess this is DVOM. I'm not sure I understand why that's VOM on all of them. Looks like I have a bug. To see if I can figure out where that is. I look at the model, Oh, well, okay, so I'm not going to worry about that now. And then it has Armington composite goods that has what are the intermediate demands. So this is the Armington composite input to Y. This is the input Armington composite input to final consumption. And then we have the net supply from this guy, which is this is the net output of A0. So there's an aggregate absorption and absorption then. So we're operating at the level of trade within each state. And then there's a combination of the state output together with national output. And then there's also then a combination of those national inputs together with imports. And local goods, again, we have a supply of local goods and demand for local goods. The supply is from a CT function. So if I look at the MPSG model here, MPSG model, it's going to be, this is the out axis PD. So if I look at PD, so that says the domestic output of commodity I in GTAP region R, state S, that's VOM, and that is allocated either to the national market, which has a price of P of IR, that's XN0, or it gets used in the local market XD0. So D is the sort of local supply, and there's a national supply. So we're keeping track of how much, and for certain sectors, like for service goods, the domestic supply is large and the national supply is small. For other goods, there may be more trade going on, and that's the reconciliation of trade determines those flows. And then this then is the national market. Again, this shows, this is from the national market is the supply of all international trade, which includes exports of services to international trade services. This is bilateral trade flows, VXMD. There's the supply from the national market to absorption in the states. That's this ND0. And then here's the output of XN0 is from the aggregate supply. So the X activity supplies into the national market, and then certain of those goods get consumed back from the national market into the states. Others get used in international trade, and other gets used for services on trade. So here we have consumption, and this is going to be the consumption good for investment. Anyway, so you have final consumption for households, and let's see, this is going to be, there's some transfers going on here. So this is household savings, household taxes. So that's the demand. So goods get produced here, and it's also used for taxes and for savings. And then, so this captures the basic logic there. And then we have primary factors rents, which are primary factors can be used in production in Y, or they can be used, they may be allocated, again, this is the GTAP specification that may be transferred transferred across different states through FT, and the endowments then are by household. So if I go to the demand block for a household, so this is showing what the household is. Household in region R, region S, household H, buys its own consumption good, that's PC of RSH, that characterizes the composition of its demand. And then it's endowed with factors of production, which represents the household shares of labor and capital and so forth. And then it also is subject to taxes, and it may be engaged in savings. The current model has exogenous savings. So there's no, you could put in a marginal propensity to save, constant marginal propensity to save, but this one just has fixed savings. The government, on the other hand, grabs the taxes from all the households. So that's the tax liability, the taxes get consumed. And the government also, if we do a search for GOVT, you can see that taxes are also levied on RTM import tariffs, export taxes. There's also taxes on absorption of domestic imported products and domestic. So there's a bunch of tax revenue that again are taken largely from the GTAP framework. And then finally, we have an investment activity, which there's an investment has savings from households it collects, and then it turns on and uses those money to buy the investment good. So in the current version, the investment composition of investment across state subregions is fixed. So that's a Leontief structure. So you have investment operating at the national level with the fixed shares across states. Again, you could make that price responsive, but in the current version, it's just a static model. And the same thing for the government, that's sort of an accounting identity. And then you've got so that's the basic, captures the essential ideas that we're trying to capture. Where do people get their money from? Where do they spend their money? How much they save, how much they have a liability for taxes. And so that's calibrated to the various components of the data set. Zero profit. So again, that's just looking at the same data files then are used to the net put vectors determine what the profitability is. And so here I'm adding up the value of output minus the cost of inputs has to be break even. The value of consumption, the cost of consumption have to break even. The disposition, that's the allocation of goods between, so you buy output in sub-region S, and then you're going to sell it in the local region or see, this is to the national market. And then there's an Armington demand. So this basically just looking at where stuff goes and where it comes from. Yeah, I'm not doing a very good job here. It'd be nice to, the problem is that the thing operates, but there's lots of details here about how you keep track. I mean, the fundamental story is no different than the stories, the little models we went through yesterday. It's basically households are endowed with factors of production. They sell those factors of production, they turn around and buy goods. And the goods they buy then determine their well-being, and then we calibrate it to an initial equilibrium where there's certain shares, endowment shares, and the thing actually puts together. So if I go now to my to the model, let's go back. I'm going to go away from. Oh, but yeah. So one of the cool things here is that you may not is that when you run this thing, then it generates the PDF file gets generated from the input file. Let me just go now to the actual model. I'm getting flustered. I can't get flustered here. Can't remember now. That's not where it was. It was. What's the name of the directory you're working with? I can't remember now. I'm just drawing it. It was called, yeah, you called it, you had a name for it. It was called, where did we put this? Let me close this for a second. I'll be right. I had this, I need to find this directory. I know I sent it to you from this machine. I just can't. Just go see. I know I put it. I can't believe I'm so stupid. I don't know what I did with this thing. I sent you the link, right? That would be helpful. Yeah, I don't know. I'm not getting Martha. Oh wait, Martha. I don't know. I'm just stupid. Sorry. I'm sorry about this. It's like, how stupid am I? Okay, my apologies, everybody. I just, I get too many things going on. So stupid. I must have, I don't know where I was working on this thing. I had the whole thing sitting up there this morning and I don't know what I did with it. Should be under D. Okay. It's not bad, it's run. Okay. Okay, my apologies, guys, for being kind of clueless here. We worked hard on this and now I always drop the ball. It's like, I wish this thing would go away. Okay, so now, let's just go through. I'll share with you what the how this thing gets reconciled, and then so if I look at the GMS files we have in this directory, we've got GTAP data is the canonical data input routine for GTAP 10. GTAP underscore model is the GTAP in GAMS model, which is documented. So if you want to know about that model, then you just do a search for GTAP and GAMS, Rutherford, Lance, and this is all. So that one is documented up here, right? So that's from a couple of years ago. The update, the version that we'll be producing that runs with version 11 will cover version 10 and version 11, but all the documentation of how the thing is read is there. So the interpretation. The WiNDC data and WiNDC model are for the WiNDC data set and model, just national. There's no international. The international imports and exports are there, but there's no bilateral trade flows there. So if I look at these models, the GTAP model does not have subregions. So we have Y of G comma R of supply by commodity G, including consumption, investment, and the government, and by imported sectors M of I comma R, and it's got factor transformation. And so that's the basic structure of the GTAP model. Again, that's documented here. It's not a very big model. Again, what's nice about GTAP and GAMS when it's MPSG, it's basically 2 pages long. You can almost print it on one sheet. And it's got all the structure. It's a little bit, there's some things that are a little bit tricky here. It's got, the trade aggregation and so forth. That's a little bit messy, but that's documented in the file. If I look at the WiNDC model, on the other hand, so this is just the WiNDC model that works by region. Again, what's going on? I don't know why these guys are not lining up. Do you have a different tabination? I do. I don't understand. It's like, yeah, I don't understand. This is weird. I use 8 character. I don't understand. And then we've got production, disposition, armature. So this is all the R that appears here. S, there's a little bit of an issue about names, but in the WiNDC model, we use S for sectors and R includes all the states. When we move to GTAP WiNDC, we use S to represent subregions. R is going to be countries, and we use G and I to represent goods and sectors, right? So that's a little bit different. So this, God, I'm amazed that this stuff is all so different. I don't understand. So it looks to me like that's got screwed up. I don't know. It's just a matter of how it looks, but why doesn't 8 character tabs are what I always use. And that used to be GAM standard. I don't know, understand. It must be that somebody is touching this with Atom or one of these other. But the number of tabs should be anyway. So here's the code that basically takes these two models, takes the GTAP model and takes the WiNDC model and combines them to make a single model where we're disaggregating both. The US national market is disaggregated into 50 state level markets, and the single representative household in the US is disaggregated into 250 households, where the shares follow what comes from WiNDC. So there's the GTAP model. We write out a stub model where we basically create a default sort of rest of house sub-region in each region. So we basically add some sectors to that. And then I basically then say, okay, if I have a stub model where all the regions in the GTAP model have a separate regionalization, can we solve that? And that's verifying that the thing that our handoff worked at that point. And then at that point, we then check to make sure that the WiNDC model operates both for the CPS and the SOI data. So this WiNDC model, again, if I look at that one, that's simply this composite. And there we're working for a data set, which is the CPS model calibrated to a static, where we don't worry about the reconciliation of investment and savings. We just have a static data set. GTAP regions, a number of dimensions. The number of dimensions could either be 11, is it 12, 10 or 32. So there's 10 dimensions for the publicly available version and 32 for the version that for people who have the GTAP data set. Okay, and then we have, so that's got those two different household variations. And then we get down to where the balancing takes place. So balance is where is operated here for, it can work for either of the household disaggregations. This says, what's the WiNDC data set we're working with? What's the GTAP data set we're working with? What name do we want to give to this file, to the output? And so that generates the two different models, the balance models. And then once we've got those balanced, then we say, okay, let's verify that we have a benchmark, that the data set that's been constructed can be represents the benchmark equilibrium data that's set. And so that's what we do inside of this GTAP WiNDC _MGE. So that's looking like this. And so now we have one of the things that's a little bit annoying, but this is just the way it is, that once you disaggregate enough countries, states, households, you have to be careful that you need to be able to declare exactly what is being used. So MPSG requires that it insists that I tell it exactly what sectors are in the model. And if there's a sector that's empty, it wants me to suppress that generation. It's just the way I designed that in the MPSG because I wanted to know exactly what's in the model. So these exception operators, the $ means such that, and then we're keeping track of which ones are active through that. And the same thing goes on with the markets. So I put in logic that keeps track of which ones are active. And then this represents then the production. So this is production of good G in country R in sub-region or state S. And that represents, if we look at how this works, we have primary factors, which may be mobile. If it's an oil or a natural gas sector, there may be specific factors, or agricultural sector, that's PS. The PZ is the input, composite inputs of good I, region R, state S. So VAFM represents that, and VOM represents the value of sales from that. So this is by country, by region, by sector. So if I look at how this operates, let's just say search solve. If I do this model, so that goes through and does a check, and I see that the handshake on the model is 10 to the minus fourth. That says it's fairly precise. It's a pretty precise handshake. And if I look at, I did that with a save. This again, just a trick. If you do it with a save, then you can basically go out and look. If I look at prod : a replace. So if I look at, there's oil.usa.iowa. So this then is an example of an activity. There are the intermediate demands. So here we have capital and labor inputs. There are the inputs of the different types of factors, technology. So lab is unskilled labor. You have service workers, clerks, and technology workers. And then this is representing the intermediate demand. Oh, there's managers as well. So that represents the composition of factor earnings. And this represents capital inputs. And then we have intermediate demand. This says for the output of oil in Iowa, this tells us what the intermediate demands are. So we have a basic representation of the benchmark. And this is what gets constructed, so that the flows that go into this file are what gets constructed in the balance routine. So that's just a handshake, verify that we have a precise handshake, that the data set is balanced. If I then go to run.gms, so that gives me the two, and I verify that I have a handshake both for the SOI and the CPS. 2014, we've just got the 2017 data set for GTAP, and we have 2017 data for WiNDC. And I've verified that I can run the thing through. I don't have the data file here, but basically we can run this thing through. So there'll be two versions that you can run, one for 2014 and one for 2017. So finally, for this workshop, I wanted to provide an operational sort of illustration of an application with the model. And so that's what this TQ model is, the tariff quota model. So this illustrates, if you compare GTAP WiNDC MGE with TQ model, that's the way I typically feel like the way I like to have one data set that checks the data consistency. That's the WiNDC. It's got a simple set of structures. And then there's another data that may have additional features for the model. And if I look at how the TQ model operates, again, most of it looks similar to the other model, but the key difference here is that if I look at PQ, this shows that the bilateral, this says, okay, we're going to keep track of what bilateral trade flows are. So here we have a benchmark in which we've inherited in this data set what the tariffs are. If you're going to relieve the tariffs but have a quota on the imports, you can specify what the quota limits are, and that's this PQ of I, RR to R of Q. So Q is the set of quotas, including in quota and out of quota. Yeah, so there's Q. I don't understand what's going on with these tabs. It's like weird. So quota levels in quota and out of quota, there's two types of trade. And if I look at the bilateral trade model, this is bilateral trade from region R into region RR into R for quota category Q. So Q is either in quota or out of quota, and they each have their own. If I look here, and we just line these guys up. So here, if you look at the trade flows, they each have RTMS underscore Q is what the tariff rate is on quota category Q on this commodity between those pairs of countries. So that means that you can take an existing high tariff and you replace it with a low tariff with an upper bound on how much is allowed to come in at that quota. So this gives you an endogenous control over, because then you have a certain number, when you roll back the tariff on the out of quota or in quota trade, you can release the tariff quota that gives you an upper bound on how far it goes. And then the key point in this sort of example, it's where the complementarity plays an important role, because which ones use the out of quota flow has to do with what happens to demand to the price. So if the price gets driven up, then you end up bringing on the out of quota trade, and the tariff will drive the price higher. Otherwise, if the price is not high enough to justify that, then it'll stay with the level we have there. So that's that. So they each have, yeah, they each have RTMS underscore Q is the tariff rate at that quota. So that's, so as you have an upper bound on how much you're able to import at the first quota and the in quota level. Once you hit the quota, then you'll be at that level until the price gets driven up to the point where you're willing to pay. If the domestic market is willing to pay the out of quota tariff, then that will come online. Yeah, so if you wanted to have Q be more than just in and out, but you wanted to have multiple, then you could do that. Yeah, so that right now Q is a set, which I currently have just in and out of quota, but you could have quota level 1, quota level 2, quota level 3. The key thing is we're relying on convexity here. So it means that it's going to use the cheaper stuff first till it hits the bound, and then the price gets driven up. But the key thing you get from the complementarity formulation, again, this is sort of a messy example, but that's the nature of the beast. When you do bottom up and you keep track of the stuff, it gets messy. But this is exactly what Jim went through yesterday. You have activities which may not be active, and then they become active at the right price. And it's all driven by the interaction between, notice that the PQ, it says, if there's a quota, this $ quota says, if there's a quota, so you could have a flow at a given tariff which has no upper bound, but if you have a bound that says such that quota, so where does that come from? I look at PQ, there's an endowment of what the quota level is. So quota of IRRQ is how much you're allowing in at quota level Q of commodity I from region R to region RR. And that's what's driving this. It's yeah. Again, this is one of these things where part of the reason I produced the oil sanctions model is because I really think that if you're asked to analyze in detail something that has multiple quota levels, you're better off in a partial equilibrium model. I mean, otherwise you inherit, if you know that, if your first order impact is, you know that the order of magnitude is that the result will be in the fractions of a % of welfare, then why do you have to have all this detail? It's better just to extract the stuff that describes that market and develop a model that goes for that. But I don't know if that's the right answer. It may not be the answer you guys are looking for, because I know that at Commerce, you're under time constraint all the time. It's helpful to just grab the model off the shelf and run with it. But I somehow feel like the partial equilibrium models, for if it's a detailed analysis of a particular quota regime, it's better just to build a model to match that question rather than carry around all the overhead. And you like to let it run overnight. Yeah.
Operate under the time constraints which were given.
Yeah.
Which are often less than 12 hours.
So the problem is, the main problem I see is that when I went to do this example, the problem is you're just carrying a lot of machinery around. That's the problem. Whereas if I think, yeah. I'm just thinking about the again, getting back to the oil sanctions model. That's all lightweight, relatively few data. The question is whether you get criticized because you're not carrying along all these other markets along with this, right? Yeah. Yeah, that's that. So I don't know what to say. I guess. The thing is, I just feel as though if I were asked to do an assessment of a quota regime that had multiple regimes and lots of stuff, I'd be looking for a model that has 3 classes or 4 classes of equations with a couple data files, and I'd like to try to run that first before I try to, rather than having a big G model that has lots and lots of stuff coded. But here's an example of a quota thing. So you can do it. I mean, so let's just look at how this works. So if I say, okay, let's set up a short run model. So I'm saying, okay, I want to look at quota reform, but I don't want to have capital mobile. I want capital to be something specific to the sector. So I'm thinking about a short run impact of quota reform. That way we get a sense about what the effects are in the individual. So here's the logic to convert. In the normal GTAP model, capital is mobile between sectors. So here I'm going to make it so it's specific to the sector. Again, you have to mess around a little bit, but set the elasticity of transformation to 0. That fixes the capital stocks. And I say, okay, well, what items do I want to report? I want to know what happens to production, absorption, imports, consumption, factor prices. I haven't added welfare there. Oh, I guess consumption is welfare. And then I want to know the level value. I want to know the real value. So level value will be an index. Real value will be dollars. The percentage change from the 2014 base benchmark. I'm going to put in 232 equilibria. So I put in tariffs initially. So I compute an equilibrium where I distort the economy to represent the 232 policies. And then I'm going to basically be able to report what happens on top of those. So think about this as a reform of a 232 tariff. And then I say, and I use D underscore to represent a change. So that's the delta relative to the benchmark and the delta relative to 232 equilibrium. Our model, again, one of the reasons I've been working the past week on trying to get, and I've got it running, but I don't have it here, is that the GTAP 11, the 2017 base year, will be much better for this application, because in this application, 2014, the trade flows are quite different than they were in 2017.
Is it easy to switch that out?
So in GTAP, the GTAP data set comes with 2014 as the standard one, and it also is, and 2017. And what's the other one? If you go back, what is it? I forget, 2012, is that the base year? So you have those to choose from in terms of data that's on the shelf. What I'm doing here is I don't observe it. I have a 2014 base year. I don't like it. So I'm going to apply the 2032 tariffs on top of the model, perturb the equilibrium to that point, and then do the tariff quota reform on top of that. It may be that it doesn't line up exactly, but at least I have, it approximates what's happening. So I do it. So I'm just showing you that's the scenarios I have is the benchmark equilibrium, handshake on the 2014 beta. 232 says I'm going to apply the 232 steel tariffs. Expansion of the PMT capacity says expand the quota. And then I have one that's a tariff quota, replace the 232 tariff by tariff quota, where I permit a certain amount in at a lower tariff rate, and then I have an upper bound. And so I don't know, the thing is, if you wanted to have multiple ones, then you'd have to change the set that I have here. So, and then I declare, once I've got that, then I declare a parameter that's going to hold the pivot data. I declare, so I have a pivot report, and I'm going to keep track of trade flows in PMT, which PMT is primary metals. That's the only sector. And again, when I did this, then this also got me to thinking about the having disaggregated. If we want to disaggregate PMT, then if we had a link to the Exio-based data set, then you could replace primary metals by, like, I think there are 4 or 5 products to be disaggregated. So that's current. The fact is that it's a lot of heavy lifting, and it's very specific, and whether or not I can deliver something that's operational for within 12 hours, I don't know. I think it's more likely, if I were young and energetic, and this was my task, I would want to have a suite of partial equilibrium models that characterize what the range of questions are that I'm going to be asked. So when the query comes in, the first thing I do is hit the button to extract the data and run this partial equilibrium model to understand what the effects are, and then have a way of peeling that back to get a handle on how much difference we get between the partial equilibrium and general equilibrium effects. So that'd be my approach, would be to first keep the simplest model And again, what I illustrated today with the oil sanctions, that's the way I would work. I keep it really simple, right? So here, let me just show you a programming technique. Again, this is, I cannot shift back and forth. And Jim's entirely right. I'm like hard to follow because my mind jumps around. But here, this is a programming exercise for how to do a subroutine in GAMS. So I want to be able to generate a solution and then generate a report. So what I do is I say on echo V that says, okay, I'm going to start echoing the following GAMS code into a file called report in the Scratch directory. So GAMS keeps a Scratch directory you can use for temporary files. And so I write the report file out there. And then I write all the code I need for reporting. So that's all the reporting code that goes in for the scenario that goes in there. And I do a verification. And now after I've verified the benchmark data set, I verify that I'm precise to at least 2 decimal points. So I check that. And then I generate a report of the benchmark replication. And that's by doing the on echo to write the report, then I don't have to repeat that code. All that code to do the reporting doesn't have to be rewritten after each solve. It's all written out there, and I can ask it to do it for each one, because that's, if I look at the report.gms, it has the %1 says whatever the argument is to this file it's about include. That's I stick the label that I'm handed in as the first label. So that way I can get a set of results back into a pivot report. And so now I'm going to do I apply the 232 tariffs. So I basically report what they are, say, okay, well, what's the tariffs on the PMT? And then I apply those to the 232 tariffs on those guys. And then I generate a save file so I can rerun it quickly. And then I queue this up and solve it. And then I move I save the point file so I can resolve it, and I generate a report. So that's the 232 base year. And then I say, okay, add an in quota bilateral trade activity. So it's saying, okay, we're going to have in quotas, guys. I calculate the value of the benchmark imports. At that point, I put in this bilateral trade activity, and I basically I do a benchmark replication. So the in quota tariff is simply equal to GTAP rate of protection. And then I basically assign the tariff rates. And now I do it here. I'm just doing a double check that I have the bilateral trade flows represented, and everything gives me a handshake. So here I double check that I can replicate the base year with the bilateral trade flows. So now the model's operational, and now I can move forward to doing scenarios. So I can calculate an equilibrium in which the PMT capacity is expanded. So here, the shock I'm doing is I'm going to make the model actually do something. And that's what you were talking about, how you're asked to do these simulations where nothing happens. Here, I'm going to just basically make a brave assumption that I'm going to say a bunch of additional capacity comes online. So I read in here saying, okay, let's assume that the capacity in certain of these regions has expanded. And that goes into my policy table. Where did policy go? Oh, I'm sorry. So this guy is coming. Where's my policy? I'm going to look at my XLS file. I did this. TQ model is my spreadsheet. And this has both the model inputs as well as the model outputs. So this is the trade policy simulation I have. Here are the 232 trade partners: China, Europe, other OECD, rest of world. The dark areas are just for my information. I put some stuff out there just so I can see what the trade flows are. This is the benchmark trade flows I have in PMT. This is what I assume the 232 tariffs are. Here I'm going to do a big shock where I assume that China triples their steel capacity. I'm just doing it to be provocative. I don't know, the thing is I'm saying, okay, there's an exogenous change. This is what that's what the quota is on in quota. The in quota tariffs are 2%, and the out of quota tariffs are 25%. So I apply a 250, 232. All the tariffs in the benchmark are essentially zero on this stuff. So I put in the 25% tariff, the 232 tariff. I put those guys in. I do the shock, and then I'm going to relax the 232 tariff with a quota on how much can come in the low tariff rate. So I'm going to relax to the 2% tariff rate up to that level. And you can read here, for example, China imports to US in the benchmark data set in 2014 was 7.6. and I'm going to give them a quota of 3. And this says that in Europe to the US as the 2016 has 17%, and I'm going to give Europe a quota of 5. So I basically put in quotas there that represent what the flows are, and then I can specify the in-quota tariff and the out-quota tariff. So that's all the policy is represented here. It's a very simple idea. I find that if you're working with someone who wants to look carefully over your shoulder, this is a very effective way to operate. You put in one sheet that has all of the input assumptions, and then you put in the sheet that has all of your results. So that way, someone who's working with it can see, okay, what's the Hicksian equivalent welfare effect across households and across states. So you can see which households change relative to the 2014 benchmark. And I could say, for example, item could be, the scenario could be, so that's tariff quota 10 and so basically this represents the range of results. I'm not going to go through this in detail, but this basically I'm showing more sort of how you set it up. And then this shows the charts on what happens to imports by state with the tariff quota and the 232. So the 232 tariff, we have a big collapse in tariffs because we basically are raising the import tariff by 25%. And then in the tariff quota, we're relaxing some fraction of that import is relaxed, and the tariff rate is set lower on those imports. So again, I didn't have much guidance. I was just trying to do something to illustrate how this can be structured. But this then gives you, and I'm using the same tools I did before, which is basically generate the reports and then dump the stuff out into the pivot data, and then, and move the stuff across that way. And that's what's going on inside this model. Let's see, if I go back, TQ model. So that's TQ model, generate the reports, and then I add, once I've finished my simulations, all the simulations are happening in one file, then I generate some additional reports, and I do stuff as percentage changes relative to different base years. So this is where all my reporting gets cleaned up. Once I've got it all reported, then I basically then say, okay, now I've got it done. I generate the data out to a pivot. I generate pivot data and trade out to pivot report.gdx. And then I say, okay, grab the data from pivot report.gdx, put it into TQ model.xlsx, and move both the parameters out there. So that's doing the reporting. So this has got sort of from the beginning, then it goes out and grabs the input assumptions, does the calculations, dumps the stuff out. A lot of policy specific coding went in doing this, right? So this is the disadvantage is that this has got, yeah, so I don't know whether I can produce a tool that will satisfy what your parameters are. I don't know. I guess, yeah. Yeah, okay. I'm focusing on you guys because you're here, so it's like, So this is an example of a calculation, and I'm open to questions. I guess we'll come back. Let me just go here. If I go, it's time for a break. We're going to take a break, and then we'll come back and I'll field questions. We'll circulate the link to this file for the. Oh no, it's going to be posted next week. So this file will post next week because we don't want to post the full thing. So, but we'll maybe take questions after the break and see if other people have any other things they're interested in. 2:30. So we'll be back in 15 minutes.